Okay, so today's lesson is called equivalent trigonometric angles. Let me write that down. Expressions. Equivalent trigonometric expressions. Over there. Alright. And so, I'm just going to do a couple of examples. Again, I'll explain all the theory in class. Given that sine of pi over 6 is equal to 1/2, show that cosine of 1/3 is also equal to 1/2. And so what you have to basically start out as is you have to show that cosine of pi over 3 is equal to cosine of somehow you would say it's pi over 2 minus pi over 6. Okay, and again I'll just kind of quickly show that that's true on the graph here. Pi over 3 is right here. Now this is a third of a rotation. Here's a third, here's a third, and here's a third. Then if I break these into each of these thirds into half, probably ignore that piece right there, then these are all sixths. 1/6, 2/6, 3/6, 4/6, and 5/6, and then finally a 6/6, each one of these dots here. And so this is a 1/3 pi. And so basically, how is it that cosine of pi over? Basically, all I'm saying is that if I cover up the cosine, I'm saying that pi over 3 is equivalent to pi over 2 minus pi over 6. And if I think about that, this is pi over 3 right here. Now, if I go to pi over 2, and then I subtract a sixth of a rotation, then I end at pi over 3. So pi over 3 is pi over 2 minus pi over 6. Okay? So we start with that. You don't have to show this each time. You just have to start. You can start with this. Okay? Now what you have to do is look at the list of equivalent expressions here. And they're found in the book on page 244. The list of equivalent expressions says that, I'm going to look at this one right here. Sine of an angle is equal to the cosine of pi over 2 minus that angle. And so, if I look at my situation up here, it says that, I'm going to write that down. Note that the sine of an angle is equal to pi over 2 minus that angle. Okay, so now what I'm going to say is, well, look. Oh, shoot, I messed that up. I'll write it here. The sine of an angle is equal to the cosine of pi over 2 minus that angle. That I just got out of the book. Now I'm saying, okay, well, the cosine of pi over 2 minus some angle, I can rewrite that as the sine of pi over 6. And then, but wait, the question actually told me at the very beginning that pi over 6 is equal to 1/2. And so, in the end, I have shown that the cosine of pi over 3 is equal to 1/2. Show that. Unfortunately, this is a little messy right there. So basically, we're given the fact that sine of pi over 6 is 1/2. We need to show that the cosine of pi over 3 is 1/2. So you start by showing that the cosine of pi over 3 is equal to the cosine of pi over 2 minus pi over 6. And then you use one of the formulas from the book to show that the cosine of pi over 2 minus pi over 6 is actually equal to the sine of pi over 6. And then the sine of pi over 6, we already know from the start, is equal to 1/2. So therefore, 1/2 is equal to cosine of pi over 3. Alright? And there you've shown it to be true with that. We do one more example here, a totally different example. I'll do it right here, actually below. Let me just move the camera instead. Okay, so let's say given that cotangent of 4 pi over 9 is equal to tangent of z, find angle z. Okay. Now, what we want to do is, again, look in the book here and say, all right, well, I've got already, to start with, cotangent of something is equal to tangent of something. So what I want to do is I want to look in the book for a situation where I've got cotangent and tangent all set up already. And I'm going to go with this one here. I don't want to go with this one because I'm trying to find tangent of z. Note in the question, I'm trying to find tangent of z, not cotangent of z. And so I want to find so this is the right one, not this one. So I'll write this down. Tangent of x is equal to cotangent of pi over 2 minus x. Okay. Note that tangent of x is equal to cotangent of pi over 2 minus x. Okay, so now actually what we want to do is take this 4 pi over 9 and we want to make it in this form. How do I take 4 pi over 9 and put it into this format over here? Well, we could do it graphically like we did up here. I showed you graphically up here, but now I'm going to do it algebraically this time. What I want to do is I want to say that 4 pi over 9, I want to rewrite it as a 2 pi minus some value x. Okay, and so now I can actually find out what this value of x is by doing some algebra. So doing this algebra, I would say 4 pi over 9 minus pi over 2 is equal to a negative x. I just took the pi over 2 and passed it over to that side of the equation. I'm trying to find x basically right now. Passed it over to this side of the equation and changed the sign. And so now it looks like I need a common denominator. 8 pi over 18 minus 9 pi over 18 is equal to a negative x. 8 pi is a negative. Pi over 18 is equal to a negative x. And then the last thing I'll do is change every sign. So x is equal to pi over 18. So basically what we've discovered here is that 4 pi over 9 is equal to pi over 2 minus pi over 18. Okay? And so now what I can do here, I'm going to take this and write it differently. I'm going to say cotangent of, remember 4 pi over 9 is actually equal to this. So I'm going to write it as pi over 2 minus pi over 18 is equal to tangent of z. So cotangent of 4 pi over 9 is equal to tangent of z. Since 4 pi over 9 is equal to pi over 2 minus pi over 18, then cotangent of pi over 2 minus pi over 18 is equal to tangent of z. Hopefully you followed that logic. If it didn't make sense, rewind it and make sure you got it down. Okay, so now since we've got this, and we know that this formula is true, the cotangent of pi over 2 minus some angle is equal to the tangent of that angle, because these two variables are the same in that formula. Then therefore z is equal to pi over 18. And that question is finished as well. Those are the only two examples I'll put on the video. All these questions will be done exactly the same way. Make sure you have it good.